Hey everyone, I hope everyone's nice and warm, because here on the East Coast it is cold. We had our first snowfall this year. Last night we got about 4 inches. The good thing was I did have to get up and go to work this morning, but I went in at regular time. Roads were completely clear. That was surprising. So the temperature didn't really get down at a hard freezing, so it wasn't too bad. But come home, I'm out here in the shop and decided to do a little quick video. What I got here is the Hallicrafters. This is the PS-500, and there's a special piece of equipment that this is going to be hooked to, but we'll do that in another video. And before we go connecting it, this was bought from an individual, and I don't even know if it's been tested out, but you know, it looking through the grill, it looks like it's all original. It hasn't been recapped or modified or anything, but we'll go ahead and pull this thing apart and take a look at it and get it ready for the piece that we're going to be connecting this to. Let me go ahead and get all the screws out of it. Should be 2 here on the back. Takes off this cardboard. I see we got a little ding down here in the bottom that we'll need to fix. That shouldn't be too hard to do. I'll pop these 2 screws here out. I'm hoping we can pop this rear panel out. Now the owner of this also bought a capacitor kit, and I'm looking at the kit and I see a problem. The capacitors are good, high quality capacitors, but we'll get into that in just a little bit in a minute, and I'll show you why there's a problem with this capacitor kit. Alright, so now all we got to do is remove these 6 screws from the bottom, and the power supply will slide out. We do have to disconnect the speaker in here, so we don't yank on that. But I'll go ahead and get this out of the cabinet. Okay, so there we are. Got the cover off. We can see our rather large transformer. Have a bias supply potentiometer to adjust the bias. A smaller transformer here, and you can see 3 can style electrolytic capacitors on top here. And if we take this and we'll turn it over, I'll tell you, the thing is pretty heavy also. It's got a little weight to it. And I'll reposition the camera. Okay, so right over here you can see that small electrolytic can capacitor sticking up right here with 2 terminals on it, and there's 350 volt caps. It is C204A and B. They are 30 microfarads, and I'll open up our package of capacitors here, and let's see what we have here. Here we go, 33 mics at 450 volts, so we're looking good on that. When we place those, we got our 2 bias supply capacitors here. These are originally 20 at 250s. We got 2 22 mics, no problem. And over here you see there's 2 large electrolytic capacitors. Here they're a single terminal. and they are 90 microfarads at 500 volts each. And this is the replacement capacitor, 100 plus 100 at 500 volts. Everything looks good, right? Got all the capacitors we need. Not really. And I'm going to show you why. Okay, looking at here our schematic, we're coming off our bridge rectifier, which uses 8 diodes in this bridge rectifier. And you can see we come here, we got 750 volts at a half an amp. And you can see there's two 90 microfarad capacitors at 500 volts. They have these two capacitors in series. And they also have some 15K balanced resistors across both capacitors. So that's pretty much standard, you know, you see that about everything. If you noticed here, one capacitor is grounded. There's our ground wire going to a negative side of our bridge rectifier. And you can see one wire comes to the ground side of this other 90 microfarad capacitor, and then we have our B plus. So you see the problem here already a bit. If you see this capacitor here is insulated. If you could touch this capacitor on the other side, you would get a pretty nasty white at about half that voltage. So you see this capacitor is paper. It's electrolytic metal can in there, but it's got paper around it, and this is so you can't touch that and get electrocuted. So it's completely insulated from the chassis. So these capacitors are going from negative, positive to negative, and then positive for your full voltage. This supply capacitor has one negative terminal, two positive terminals. Will not work in this configuration. The reason for that is it's 750 volts. If you was going to replace this with a single capacitor, you would need a capacitor that could handle that voltage of 750 volts. So you're looking at 850 volt electric capacitor. Hard to find. So by using two capacitors in series, that's 500 plus 500 is 1000 volts. So you got a good headroom. This capacitor is a good capacitor, and it's a JJ, but there's no way that you can use this because you got one ground terminal. So what I might probably end up doing, I could use two 450 volt caps. That would give me 900 volts of the 750 100 microfarads in series. My capacitors that I just ordered has not arrived yet, and I do not think I ordered anything in the 100 microfarad range. I ordered $200 worth of capacitors, and I don't think I even ordered anything close to that. So I'm going to have to go back online and probably order 200 microfarads at 500 volt caps and put them on a terminal strip here. So that part we won't be able to do anything with, and you know, those capacitors need to be about the same, and so that, you know, the circuit will be balanced out pretty good. You know, if I had two of these, you could use just one positive terminal to negative, and so forth on the other one. But that's quite a bit of money to spend to do that with. So yeah, I'm gonna have to go online and order the correct high voltage filter caps for this. You know, guys, I've been a little slow at getting videos out. I will admit that, and I'm sorry for that. You know, most of the time I try to make videos that are close to an hour long, and I think that's the wrong approach. Now, I'd like for my videos to have quality content instead of just rambling, stupid, you know, kind of stuff. A lot of people like that, but a lot of people come to this channel because, you know, we try to be more serious in the repair, you know, and the repairs we do is to help you guys. So I think what I'm going to start doing is trying to do more shorter videos. This helps it so I can get in there in the house and load them up and get them edited and go ahead and get some videos online for you guys to watch. So I'm gonna do a trial on that and just try to keep some videos shorter. That way I can get more uploaded videos for y'all's entertainment. I know a lot of y'all, you know, enjoy seeing this kind of stuff, so, you know, if I can get more out, maybe it'll be more pleasing. The channel is close to 14,000 subscribers now. Big thanks to all you guys, really appreciate it. But I'm looking at the data, and the data is just not showing a lot of growth on the channel. Yeah, we picked up a few hundred subs in the last couple of weeks, but I would like to see, you know, a few hundred subs every few days. So to do that, more content needs to be created, but still needs to be quality content. So if we look at the power supply capacitors, you can see that there's a line on this side that denotes ground, and the positive side goes to ground. And looking here at the schematic, you will also see that the positive ends of these two capacitors goes to ground, and this should be adjustable from -80 to about -135 volts, and this goes on out to pin 4 on this connector, and that's for the power supply inside the radio. It's a negative bias supply. So we'll go ahead and start with getting these old two caps out and go ahead and get those replaced, and we'll replace the other ones. The only thing we can't do anything with right now is the high voltage caps. I'll look around in the shop and see if I have anything that we can put in temporary until I can get the other caps, but we'll go ahead and finish up the rest of it and check the supply out. So all I'm going to do is just go ahead and remove these two caps, and we'll get our two new ones installed. Okay, we got our two bias capacitors replaced, and also down here there was a 100 ohm diode on that circuit, and as you can see, it was cracked. And yeah, it was cracked before I even started on. I just noticed a little hairline crack on it. When I moved the resistor, it was surely broken. So I went ahead and replaced it with a 2-watt flame resistant resistor. So there shouldn't be no more problems in that. Looked like it was heated a little bit looking at it, but that 2-watt will hold any heat that's in there, and should cause that. I also don't like the way that they got this resistor here just flung over here and hooked to this wire going on the other side of the chassis, so I'm going to do something about that. The next thing I want to do is looking at replacing this dual can cap over here. The cap we've got, you know, is a double one ground, so I'm probably going to put a terminal strip in there. I might go here and remove this little short terminal strip and move this somewhere else, that way I can get this capacitor in here and you know, give it a little more room, kind of clean it up just a little bit. Okay, I went ahead and removed the old dual 30 microfarad capacitor and have the new one installed here. Put the terminal strip here. I took this terminal strip that was sitting here, moved it back here to this bolt, and locked it down with a star washer. Put a new cap over here, and run this resistor kind of up off the chassis and over here to keep the heat away from the capacitor. And I went ahead and run a new wire coming from this resistor that goes up to our bias part. The wire that was on there was, I don't know, it's so hard and been heated that it just cracks when you bend it. So I went ahead and replaced that whole wire, got rid of that. The only thing we haven't done yet is the high voltage caps. Like I said, I got to look through my stuff and see if I got anything temporary until I can get some in. But I noticed this. You see the high voltage lead, it comes off and comes around here, and there's two test points on the other side. There's a 5 ohm, excuse me. Yeah, there's a 5 ohm resistor, and this is 5 watt. And if you look right here, you can see a crack in this resistor, and it is actually got some of the insides bubbled out of it. So something has happened in here, and this resistor acted like a fuse, and it cracked and started spilling its guts out. That means that whatever this was originally attached to on the high voltage had a leaky circuit, a shorted tube, or something was going on, because it definitely has burnt this resistor up. And I checked it, and the fuse is good, so this has happened somewhere down the line, and it doesn't look good. I'll check the resistance on that resistor just for the fun of it. Let's see what it is. And I am showing 0 across it. Anyway, in the schematic, you can see it coming off the bridge rectifier with the 2 caps and the 2 balance resistors, and then out to pin 1 of the connector. There is no 5 ohm resistor and test points in line, but we do have it on this circuit. So what I'm going to do, I'm going to check this resistor just to see what it shows. See if it's open. Okay, grab the meter here, and we'll take a look at this. Well, it's definitely not 5 ohm. Or in the 2K range. So it is looking like, make sure my meter is working okay. Just want to make sure. Yeah, that resistor is open. So we'll have to replace that. Okay, look at this. Like I said, that's not on the schematic. High voltage comes around, comes to one side of the 5 ohm resistor. Goes on the other side, it picks the red wire up, goes back out to pin 1 to connect to the radio. Looking, let's see, that's 2 90 microfarad caps in series, so you're looking at about 45 microfarads at 1,000 volts. I'm going to have to find something that'll give somewhere between 45 to 60 microfarads. at least 900 volts in it. I'd rather go 500 volts, but we'll see if we can't find something in here. I found some of these. I got a couple of these Rubicons. They are 180 at 450, so that would give you 900 and somewhere around, let's see, 50, 60, somewhere around 90 microfarads with both of them in series. That's a little bit more than what I like to put in a power supply, especially on the high voltage side. You know, holding that much of a charge. Your microfarads is kind of like storage capacity. But I just want to see if this supply is working now. And you know, to turn this supply on, you have to have it connected to a radio. But we don't want to connect it to a radio. We want to make sure that the supply is working. So what I'm going to do is pick up the two gray wires that goes off to the switch. One comes right at the back of the fuse. I'm going to hit and pull the 5 amp slow blow out. I put a 4 amp fast blow in it in case something happens. That fuse will just go away, and we'll connect to the other side that will be coming back from the radio to feed the transformer. I'm going to come here and I'm going to pick up the high voltage on the output of the capacitor. Sure everything's out of the way, clear, and I've got it on DC 1000 volts, and we're going to bring it up on the variac with current limiting and just see what it looks like. I'm going to bring it up, it's kind of slow. See, we're reaching about 100 volts. I'm saying with no load on this that voltage is going to reach up about 850 volts or so, maybe a little bit more. There's 400 volts at about 440 volts at halfway on the variac. Watching current limiting, everything looks good. Also, you got to remember these supplies was designed for a 117 volts. And there's 844 volts at 122 volts input. No problem with current limiting, everything looks good there. Voltage looks good and stable. Won't really know until we put a load on it, but I don't want to do that until those caps are brought down. I'm just letting that bleed down. You can see the bleeder resistors over here on the front. There's two 10 watt resistors, and they're 20K each. And it's bringing the voltage right on down, no problems. I'm going to come here on the 300 volt supply. And I expect that this supply is really gonna go up there since there's no load on it. And there we are, about 419 volts. Now we're gonna come down here and check our bias supply. That's a negative 126 volts. So all three supplies are working and looking just like they should. like I say, you know, you want to get a little more voltage on it due to no load. So supply's looking good. We just got to figure out if I can find something in the shop to replace those with. Like I say, I don't really like putting that much in it. These are good caps. 900 volts should be enough. On the load, it's not, should not go much over about 780 volts, maybe 790. But you know, if it don't go no more than that, 450 volt caps will be fine, because say that's 900 volts, and you're not pushing them. You're leaving a little over 100 volts there for some headroom. So I imagine there's quite a few of you back there screaming at me about what this resistor is for. It's actually high voltage current shunt, so you can measure the amperage on the high voltage, and it's just done by, you know, measuring on both sides of the resistor to get the plate current, and that's exactly what this is for. So I don't have a 5 ohm sandbar resistor. Let's say this is 5 ohm, 5 watt. So I'm going to replace it with 2 flame proof 10 ohm resistors in parallel. And I went through some stock and found something that give me a good 5 ohm rating. So that's what I'll replace that with for now. I've got our 2 resistors installed. Check across it, see how close we got, and 5.0 ohms. So there shouldn't be no change in the reading when you try to read your current. So again, back to the high voltage supply filter caps. You see we got 2 90 microfarad caps in series, and when you put 2 capacitors in series, you double the voltage. In this case, it's 500 volts each. That gives you 1,000 volts for this 750 volt circuit. But when you put capacitors in series, your value goes half. So you're looking at 45 microfarads of filtering for this circuit. So after some consideration, you know, I thought about if I was to put 2 of these 180s in there. They're 450 volt at 180. That gives us 900 volts. It will give us approximately 90 microfarads of filtering. A little bit too much for this supply. You know, capacitors, the microfarads is the rate of storage, so we don't really want to have that much storage available in this supply. In case something happens, you know, that would be holding quite a bit of storage. So what I've done is redone and draw the schematic, and we'll put 380 microfarad caps in series. That will give us about 60 microfarads of filtering. At the same time, when you add up 450 times 3, you come up with 1,350 volts. Now, like I said, this supply was going well over 800 volts on the, you know, just unloaded. So 1,350 volts is plenty of headroom, and plus we get our filtering about where we want it. I went ahead and made a new power supply board to fit the capacitors. You can see one end of the capacitor is grounded, and they just in series, negative to positive. And then we have these tabs here that you can mount resistors to if you want to. So you could drill them out and mount 15K 10 watt resistors on top. But we're probably just going to run wires and have the resistors installed inside the radio. It depends on how you want to do it. Ground all the way around. We'll drill this out and put standoffs so it'll sit on the top of the chassis, and then just run all cabling out. Also, even though that you're grounding it directly, we'll also put in a wire that will tie to the chassis. Sometimes mechanical grounds are good, but if someone is working on something, then a wire ground. Another thing about these type of cats, when you use them, we'll put pieces on the top of them, because this case is going to be hot. There'll be voltage on top. Someone reach in and touch that, it's going to get a nasty zap. So we'll put little discs on top of them to keep that from happening. Okay guys, our power supply is now completely finished that I know of. As you can see, all the old caps back here in the back that came out of it. The burnt high voltage resistor for the current measurement, the little 100 ohm resistor that was broken in half. All that is out, and I've got this new power supply board in. I've got 320K resistors across each cap, and one goes to ground. So now if you notice, I haven't put disc on top of these yet, and there's a reason why. I'll show you that after we power up this thing and test it. Okay guys, we'll go ahead and test out the supply, see how it's working. And I don't have to tell you this because you should already know, but be very careful working on something like this. There's over 800 volts here at a half an amp, and that stuff is nasty. It can terminate your life. Okay guys, we'll go ahead and bring this thing up. This meter is measuring the high voltage DC output, and this meter will be measuring the AC line voltage. You can see just how good this power supply is working at 20 volts AC in, at 149 volts. This up at 50 volts, so we're at 370. About 68 volts, we're at 500. Volts, we're at 95 volts, we're at 705. Standard line current of the day at 117 volts. You can see she's at about 870 volts. And that's 124 volts. We're at 918 volts. Now as you can see, we're at 915 volts unloaded. Now if I was to put a load on the end of it, you know, it's going to drop it down to about 850, you know, a little over 800 volts. And that shows you now with two capacitors that was originally in here. You know, that one's 500 volts and this one's 500 volts. That's only 1,000 volts of headroom, of total voltage that these two capacitors can hold. So, you know, we're less than 100 volts on the headroom. So if something was to surge up, as you can see, it don't take much on the AC input to create 100 volts. So if this thing was to surge up, you know, 15, 20 volts on AC, that's going to well exceed 1,000 volts. And, you know, can run these capacitors hard. You can already see this one look like it has leaked already. So with the three capacitors in there, 450 volts a piece, giving us 1,350 volts. That's a lot more headroom, a lot more protection, and not working the capacitors quite as hard. I'm going to go ahead and turn the AC off, and you can see just how quickly it's bleeding down. So our resistors is doing the job just like it's supposed to. It's already down below 50 volts now, and it's coming on down. Now, I said something to you before about the tops of these capacitors, how dangerous they could be if you don't protect them. And we'll go to ground. Alright, there's 302 volts on that one. And there's over 600, well, yeah, 600 volts on the end one. Now this one at the end is grounded. This case is grounded, so it's not going to hurt it. But you know, these two are in series, so 300, 600 volts. That can get a little nasty. So to fix that, what I got here is a case where I bought a new Makita battery, and there's some plastic here. Now if you got some mica sheets or something like that, you could use those. They will work fine. But you know, the only thing you want to do is protect someone from getting zapped by this thing. So all I'm going to do is take the same type of capacitor, just trace right around them, and then cut them out, and I'll do another one out of the other piece I got over here. Okay guys, as you can see now, I have the three discs on top of the capacitors. If someone was to touch them, they will not get shocked. And you know guys, not only do you have to, when you restore and stuff like that, make it, you know, get it efficient to run, but also make it safe for the next person to, you know, that's going to work on it, or even whoever owns it. Now, you might say, well, buddy, why you do that for? And there's three resistors here with the legs exposed. A lot of people know that not to touch component leads, but some people don't think about the top of these capacitors, and that's why. Well guys, that wraps up another one. Hallicrafters PS-500, all ready to go and be hooked up to its companion radio. So I hope you got something out of that. Hope you enjoyed it, watching as much as I did doing it. That's a fun little repair to do, and did not really take that long. But anyway, we had to go ahead and fix this because we got something else that we'll be working on here in the future. Yep, Hallicrafters PS-400 Cyclone. And it's my understanding that this thing may have been converted to the Cyclone too. We'll just have to check it out and see. But it was reported that this radio was kind of dead in the receiver. So we'll be having to look at it. Shouldn't be too hard to get it figured out. Anyway guys, I hope to see your comments down below. Any questions or anything, feel free to jump in or jump over to the website at gokarters.com and have a look at it. Appreciate all the support from patrons, and guys, we'll see you in the next video. Bye now.